In the next bunch of videos, we're going to talk about the analytical and graphical connections between a function and its first and second derivatives. Basically, we're going to be able to compare the behavior of a function itself to the graph of the function and the graph of its first derivative and the graph of its second derivative. So let's take a look at page 324 in the notes, just so we can have something to look at. So we've got a table here at the top of it that you're going to be able to fill out from looking at this function at the bottom. So we've got this function here, f of x is equal to x to the fourth power minus 4x cubed. I added in a term of positive 4x. So what I would like you to do is to take that function and graph it in GeoGebra. It's going to look something like this. So here is the function. And then the other thing I want you to do is I want you to graph the first derivative of the function. So that's a polynomial function. So we've got a lot of experience with taking the derivative of that function. So the derivative of that function would be f prime of x would be what? Be 4x cubed minus 12x squared plus 4. All right, so we're going to go back to GeoGebra and we're going to graph that as well. All right, and so that looks like that, except I put in 2 instead of 4. All right, so that's the graph of the derivative, and this is the graph of the function. And based on this, I want you to fill in the table at the top of page 324. And so the way that I want you to do that is by looking at this graph and identifying the points where this function is equal to 0. For instance, there's a 0 around here, a 0 around here, and a 0 around here. And then if we see what's happening to the green graph at those points, so this is what's happening to the green graph at the first 0 of the first derivative. Here's what's happening at the 0 of the second 0, and the third one is down here. So what is the behavior of the green graph when the blue graph is equal to 0? And then the other questions they ask is, what is the behavior of the green graph when the derivative graph is greater than 0, when it's less than 0, when the behavior of the blue graph changes from positive to negative, like for instance, here it's positive and then it becomes negative, what's happening there? And when it goes from negative to positive, like it does here. So see if you pause the video, if you haven't already, and see if you can fill out that table. All right, so I am going to go and show you what I've got for this. All right, so if f of x is equal to 0 or is undefined, then f of x, let me put it this way, f of x may be a minimum or maximum. It may not be, but it's a point we need to check to be sure. And the fancy word we use for this is a critical point. A critical point just means just what I said. It's a point that we need to check to see if it's a maximum or minimum of the graph. If the derivative is greater than 0, wherever that was happening, the graph itself was increasing. And when the derivative was less than 0, that was showing that the graph was decreasing. Let's go back and check again what happens when the derivative changes from positive to negative. So here's a point where it changes from positive to negative. So it is increasing for a while, then it stands still for just an instant, and then it starts decreasing. So increasing, stopping at a top point, and then decreasing, that is a maximum point or local maximum point. And the same thing was happening on the other side. So here, where it's going from negative to 0 to positive, the graph is dropping, dropping, slowing, steady, rising. So that is a local minimum. So those are important things to be aware of. This is a local maximum, and this is a local minimum. So these are key ideas for how we can look at the behavior when we want to identify these ideas about a function. We can just take a look at its first derivative and just calculate these things using algebra. All right, we'll see more examples of this as we keep on going through these videos.